Hello, this is Mr. Huber. In this video lesson, we're going to learn about solving trig equations for final answers that are in radians. We've solved trig equations before where we were given angle measures in degrees. Well, if you'll notice now in these directions here, we want to solve for theta that's between 0 and 2 pi instead of 0 and 360 degrees. So we're going to get final answers in radians instead of degrees. We're going to solve trig equations the same as we would when we were solving for degrees. We want to get a trig function isolated by itself equaling a ratio. We'll figure out what degree measure it is, and then we'll talk about making sure that answer goes from degrees to radians. So in this first equation, we have cotangent and sine. We want to simplify that. We need to try and get that to a single trig function if possible. Since cotangent is cosine over sine, and you multiply it by sine, those will cancel. You're going to have 2 cosine theta minus the square root of 2 equals 0. Right? Cotangent times sine will simplify to just cosine theta. So now we've got a single trig function here we can work with. And we can add the square root of 2 to both sides. Square root of 2. And we'll have 2 cosine theta equals the square root of 2. And then we can divide by 2 on both sides. And we'll end up with cosine theta equals the square root of 2 over 2. So 2 there. So now we want to figure out where is cosine ratio square root of 2 over 2. That's at a reference angle of 45 degrees. That's where the x and y values are both square root of 2 over 2. Cosine is the x value, square root of 2 over 2. And cosine is positive in quadrant 1 and in quadrant 4. So we want to give an angle measure in quadrant 1 and in quadrant 4. So that's going to be 45 degrees in quadrant 1 and 315 degrees in quadrant 4. Okay, now we want to make sure we give our final answer in radians. So in radians, theta would be 45 degrees is pi over 4, and 315 degrees is 7 pi over 4. Those would be our angle measures that are our answers in radians for this equation. All right, we should know and hopefully get familiar with understanding that 45 degrees, every 45 degrees is pi over 4. It's a fourth of pi. Okay? Every 30 degrees is pi over 6. Every 60 degrees is pi over 3. And we can use those. Again, know that first quadrant, know those special angle measures, and be able to use that for any other degree measure all the way around the unit circle. All right, 45 degrees, pi over 4. All right, it's a fourth of pi. And 315 is 7 of those 45 degree angles, so it's 7 pi over 4. All right, and let's look back now at the second problem. Sine squared theta minus 4 equals negative 3. Okay, so we want to get that sine squared by itself by adding the 4 to both sides. And we'll have sine squared theta equals 1. And so now we can square root both sides because we want to get just sine, not sine squared. So we'll have sine theta equals plus or minus 1. Keep in mind we want to have the plus or minus there and we square root both sides. So now we need a sine ratio that's plus 1 or minus 1. So where does that happen? That's when we have a y value, sine is a y value of 1. Sine has a y value of 1 at 90 degrees and negative 1 at 270 degrees. So our answer in degrees is 90 and 270. That would be a positive 1 for 90 degrees and a negative 1 for 270 degrees for a sine ratio. And now in terms of radians, okay, we want pi over 2. 90 degrees is pi over 2. And 270 is 3 of those 90 degree angles, 3 pi over 2. So we have pi over 2 and 3 pi over 2 as our radian answer for the angle of theta in that problem, in that equation. Okay, and let's look at a third example here. So we've got secant squared. So how do we work with this one? We can factor in this one. Okay, so we can factor out a secant from both those terms. And now that we got it factored in, the factors can be set equal to 0. So now we can write out secant theta equals 0 and secant theta plus 2 equals 0. Right? So now when we look at this, secant theta equals 0, right? What do we want to do with that? Well, there's a couple things we could do. We could recognize that secant, okay, secant is the reciprocal of cosine, okay? Since cosine is x over r, secant is r over x. So we would want this to be equal to 0, or in this case, 1 over 0, undefined. Well, that's never going to be the case. You can never have an r value of 0. Secant, r over x right here, this can never be equal to 0. R is always 1 over anything, okay? Again, you can never have this be undefined because you're not going to have an r value of 0. so undefined. Okay, so secant theta equals 0 is undefined. There's no solution from that. Okay, so that's not going to solve anything or give us any solutions for this particular equation. Then on the other equation we had, factoring set equal to 0, we can subtract the 2 on both sides and get secant theta equals negative 2. Okay, this is the same as when cosine theta would be negative 1/2. Right? Cosine is x value of negative 1/2. So we'd want an x value of negative 1/2 for this. Right? And so that would be 60 degrees for the reference angle. Okay, cosine theta has a value of 1/2 for 60 degrees, and cosine is negative in quadrant 2 and quadrant 3, where you have x values that are negative. Right? So in degrees, this would be not 60, 120, right? Because we want quadrant 2. So we're going to have 120 degrees. And then in quadrant 3, 240 degrees. Those are our 60-degree reference angles in quadrant 2 and quadrant 4. So in terms of radians, right, 120 degrees in radians, that's two 60-degree angles. 60 is pi over 3. Every 60 degrees is pi over 3. So 120 is two of those. It's 2 pi over 3. 240 is double the 120, or it's 4 times the 60. So that's going to be 4 pi over 3 in radians. Right? And those would be your two answers for this equation in radians, 2 pi over 3 and 4 pi over 3. So good. Like solving for degrees, when we're solving trig equations, we want to get the trig functions by themselves, know how to use identities, know how to square root both sides, factoring, some of the different strategies we've already seen in terms of algebra-wise solving equations, and then we need to make sure we understand how to get ratios, the trig ratios for these trig functions, what angle measures those are. We can get them in degrees, and then take the degrees and write a final answer in radians.